Hello students, we are going to discuss test 20 today. The topic was reflection and refraction by plane surfaces. In the first question, an object is placed at 10 cm in front of a convex mirror. So the object distance is 10 cm and object distance is always taken negative. The focal length of convex mirror is 20 cm. So f is 20 cm. And as it is convex mirror, the focal length is positive. We want to find the distance of image from the mirror. We will use mirror formula here. So 1 by f is equals to 1 by v plus 1 by u. So 1 by v is equals to 1 by f minus 1 by u. Focal length is 20. So 1 by 20 minus, this is minus 10 centimeters, so minus plus divided by 10. So 1 by v is equals to 1 plus 2 divided by 20. So image distance will be 20 by 3 centimeter. So option 2 is correct option. In question number 2, a ray of light is incident on the YZ plane mirror along a unit vector 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. We want to find the unit vector along the reflected ray. Let's say this is the plane mirror along YZ axis. If this is the YZ axis, this will be the direction of x-axis. If this is the incident ray, then reflected ray will be exactly in the opposite direction. So only x component will be reversed. So the reflected ray will be minus 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. So option 4 is correct option. In question number 3, two plane mirrors are inclined at an angle of 75 to each other. An object is placed at point O. We want to find the number of images formed by the two mirrors. Here first we will find the ratio 360 by theta, that is 360 by 75, that is equals to 4.8. Whenever this kind of number appears, we will consider only integer part of the number. So number of images will be 4. So option 4 is correct option. In question number 4, it is given that a plane mirror is approaching you at 10 cm per second. So the velocity of mirror is 10 cm per second. We want to find the velocity of image with respect to us, that is velocity of image with respect to object, and it will be 2 times velocity of mirror. That will be 20 centimeter per second. So option 4 is correct option. In question number 5, it is given that an object moves with speed 5 meters per second towards right, while the mirror moves at speed 1 meter per second towards the left. We want to find the velocity of image. Here in this case, we want to find velocity of image with respect to a stationary observer. Here 1 by 1 we will keep one of them at rest. In first case, let's say mirror is at rest. So velocity of image with respect to observer will be equal to velocity of image with respect to mirror. Now object is moving towards mirror with speed 5 meter per second. So velocity will be approaching mirror with same speed 5 meter per second. So this will be 5 meter per second and it will be in left direction. Now in the second case, mirror is moving and object is at rest. So in the second case, object is at rest. So velocity of image with respect to observer is equals to velocity of image with respect to object. Now in this case, mirror is moving towards left with speed 1 meter per second. So image will be approaching object with the double speed, that will be 2 meter per second, and it will be in the direction left. So total velocity of image will be 5 plus 2, that is equals to 7 meter per second and towards left. So option 1 is correct option. In question number 6, it is given that an object is moving in this way towards the mirror with speed 10 meter per second and along the mirror with speed 5 meter per second. We want to find the velocity of image of a moving object with respect to ground. Let's say there is one observer on the ground. We want to find the velocity of image with respect to this observer. First, we will solve for the parallel components. For the parallel components, the velocity of mirror does not matter. So, velocity of image with respect to ground and its parallel component will be 5 meter per second. Now, we will solve for the horizontal or the perpendicular component. First, mirror is at rest. So object is moving towards the mirror with speed 10 meter per second. So velocity of image with respect to ground is equals to velocity of image with respect to mirror, that will be same speed as that of object, it is 10 meter per second in the left direction. Now in the second case, observer is at rest. So in this case, velocity of image with respect to ground is equals to velocity of image with respect to object. In this case, mirror is moving with speed 30 meter per second. So velocity of image with respect to object will be double, that is 60 meter per second. And it will approach the object, so it will be in left direction. So total velocity of image with respect to ground, its perpendicular component will be 70 meter per second, but it will be in left direction. So it is along the negative x-axis, so it is taken negative. Option 1 is correct option. In question number 7, the figure shows a plane mirror onto which a light ray is incidenting at an angle of 30 degree. Now the incidenting light ray is turned by 10 degree. So this is the incident ray in the second case. Respect to first case, it is turned by 10 degree. So it will make the angle of 20 degree with the original normal, and the mirror is rotated by 20 degree. This is the situation of the mirror in second case. This angle is 20 degree. If mirror is rotated by 20 degree, then its normal will also be rotated by 20 degree with respect to initial position. Now for the second case, this ray is incident ray and this is normal. So angle between them is 40 degree. So for the second case, angle of incidence is 40 degree. So angle of reflection will also be 40 degree. If this is the normal, then the reflected ray will make an angle of 40 degree with the normal. Now, if this angle is 20, this total angle initially was 30 degree. So this angle will be to 30 minus 20, that will be 10 degree. So the angle between the final and initial reflected ray will be this much, and that is 40 minus 10, that is equals to 30 degree. So the reflected ray is rotated by 30 degree in clockwise direction. 30 degree in clockwise direction. So option 1 is correct option. In question number 8, the height of man is given 1.8 meter. We want to find the length of the shortest mirror in which he can see his entire image. The height of man is 1.8 meter. So height of mirror required is h by 2, that is 0.9 meter. So option 2 is correct option. In question number 9, an unlit candle is at 90 cm from a concave mirror of radius of curvature 60 cm. Where must a flame be put from the mirror so that its image may be seen coming out of the candle? So we want to put the lit candle or flame in such a way that its image should be found at the position 90 cm from the mirror. So for that we want to find the object distance u. Image distance is 90 cm. As this image is real in front of the mirror, the image distance will be negative. Focal length is r by 2, that is 30 cm. For concave mirror, focal length is taken negative. Using mirror formula, 1 by f is equals to 1 by v plus 1 by u. So we can write 1 by u is equals to 1 by f minus 1 by v. Put the values. Focal length is minus 30 cm. So 1 by 30 cm minus the object distance is 90 cm, but that is negative. So minus minus plus 1 by 90, that is equals to 1 by u. So 1 by u will be equal to minus 3 plus 1 divided by 90. So 1 by u is equals to minus 2 by 90. So u is equals to minus 45 centimeter. So option 1 is correct option. In question number 10, it is given that a ray deviates at 90 degree. So angle of deviation is 90 degree. After suffering reflection from a mirror, we want to find the angle of incidence. The deviation through single surface is given by 180 degree minus 2i, and that is given 90 degree. So 2i will be equal to 90 degree. So angle of incidence will be 45 degree. So option 4 is correct option. In question number 11, a mirror is inclined at an angle of theta with the horizontal. A light ray is incident at an angle theta. This is incident ray and this is the normal. So angle of incidence here is theta. This is the reflected ray. So this angle will also be theta. We want to find the angle that reflected ray makes with the horizontal. We want to find this angle. Let's say this angle is x. Now this mirror and this normal will make 90 degree. If this angle is theta, then this angle will be 90 minus theta. So for triangle AOB, 90 minus theta plus theta plus x is equals to 180 degree. This minus theta and plus theta will get cancelled out. So x is equals to 90 degree. So option 4 is correct option. In question number 12, two plane mirrors are inclined at 70 degree. A ray of light incident on one mirror at an angle theta after reflection falls on the second mirror. Let's say on the second mirror it is incident at point B and it is reflected from there parallel to the first mirror. Here our first mirror is horizontal, so this finally reflected ray is also horizontal. We want to find the angle theta. If this is angle of incidence theta and this is normal, the angle of reflection will also be theta. So this angle will be 90 minus theta. Now this is the normal of second mirror. If angle between two mirrors is 70 degree, then angle between their normals will also be 70 degree. This is horizontal, these two are parallel. If this angle is 90 degree, then this angle will also be 90 degree. If this is 70, this is 90, then this must be 20 degree. So in this case, second time angle of incidence and angle of reflection are 20 degree. Now mirror 2 and these are normal. If the angle of incidence is 20 degree, then angle with mirror will be 70 degree. So in triangle OBA, 70 plus 70, that is 140, plus 90 minus theta is equals to 180 degree. So theta is equals to 50 degree. So option 1 is correct option. In question number 13, for a girl, the eye to eye and ear to ear distance of her face are 4 inch, eye to eye and ear to ear distance is 6 inch. We want to find the minimum width required for the mirror so that she can watch her face in the mirror. The minimum width required is 6 minus 4 divided by 2, that is equals to 1 inch. So option 1 is correct option. In question number 14, to travel through the same distance in two different media, a light ray of certain frequency takes different times that are in the ratio T1 by T2 is equals to 3:5. We want to find the relative refractive index. Relative refractive index is N21, that is equals to N2 by N1. But refractive index is given by C by V2 upon C by V1. So this will be V1 by V2. Speed can be written as distance upon time. They are traveling same distance. Let's say D. So D by T1 divided by D by T2. So the ratio will be T2 by T1. That will be equal to 5 by 3. So option 1 is correct option. In question number 15, refractive indices of glass is 3 by 2 and that of water is 4 by 3. We want to find refractive index of glass with respect to water. That will be refractive index of glass upon refractive index of water. So 3 by 2 divided by 4 by 3. This will give us the answer 9 by 8. So option 3 is correct option.